Hi, everyone. So let's continue with the second part of our lecture for today. In the first part, we discussed FAO data, Food and Agriculture Organization of the United Nations. Now we are going to deal with a more contested issue, which is military spending. So military spending is a core part and component of international relations. And every single day when you read the news, you always find news related to war, fear of war, and accompanying global military spending. Military spending is essentially how much money a nation spends on its armed forces. By military spending, you buy things like tanks, jets, artillery, and ammunition. Military spending also feeds research and development, such as satellite tracking data, satellite tracking technologies, artificial intelligence, missile guiding systems, drone research, nuclear research as it relates to military spending. It also pays the salary of people who are combatant aspects of the military, but also support staff of the military, such as lawyers, such as cooks, and other support personnel. So military spending is usually correlated both with how wealthy a country is, how strong it is from a very, rudimentary point of view, and also how much threat it perceives relative to others. So even though nominal measures of military spending, such as how much billion US dollars a country spends, is an indication of how wealthy it is, percentage of military spending compared to that country's GDP or government spending is usually an indicator of whether that country is under threat or under war. So, for example, a country that is not really facing any immediate threats would have a military spending of about 1% of its GDP, 1.5% of its GDP. If it's facing, moderate amounts of threats, for example, it's 2% or 4%. Anything usually above 10% is usually regarded as either that country is facing a war or whether it is under war, or expecting a war, or rapidly modernizing its military. So when you're modernizing your military, it's an extremely expensive process. And you have to pay enormous amounts of money in order to be able to modernize, especially if you have a large military. So very recently, basically yesterday, so today is 23rd of April, a new report was published by the Stockholm International Peace Research Institute, or SIPRI, in which it says the world spent 2.4 trillion on military forces last year, the highest amount ever recorded. And this basically is a new record. The total $2.4 trillion is the ninth straight annual increase in the world, which means that the total of countries spending on their military is gradually increasing. And since SIPRI started to collect data, this year is the highest military spending we had ever. So this creates questions such as, are we headed into another great war? Are countries headed into a war? Is the world becoming safer? Is the world becoming not safer? So France 24 has a very similar article today saying that conflicts pushed global military expenditure last year to an all-time high. Global military expenditure saw its steepest increase in over a decade in 2023, reaching an all-time high of 2.4 trillion. And we basically observe similar trends all across the world, where Rishi Sunak, the British Prime Minister, pledges to boost UK defense spending by 2030, which means that even the most advanced and wealthiest countries are aiming to continuously increase their military spending. Historically speaking, usually during times where military spending was on the increase, it usually correlated with major conflicts, big wars throughout World War II and World War I, and throughout the Cold War. Defense spending always increased after the split of the USSR. There was a brief period of time in which military spending declined, but it is also increasing at the moment, which brings in the question, are we headed towards a war as a world right now, which is a big question in international relations. So both news articles point to SIPRI as its source of data. So what is SIPRI? Stockholm International Peace Research Institute is essentially, it's based in, or near actually, Stockholm. And it is one of the oldest institutions in the world that is dedicated to finding a way to bring peace to the world, understanding war, understanding peace, understanding dynamics of conflict, understanding dynamics of escalation. And SIPRI has been around for decades. If you basically look up online, it doesn't have that information in its own webpage, but it was founded in 1966, and it is the leading provider of data analysis and recommendations on military conflicts. For those of you who are interested in military affairs should, I think, follow SIPRI online. So today, we are going to be working with SIPRI data. So at SIPRI.org, there's a section called databases. So we are going to go there. SIPRI Arms Transfer Database. Let's explore this. Who are the suppliers and recipients of major conventional weapons? So conventional means non-nuclear. What weapons have been exported or imported by specific suppliers and recipients? So it basically gives you a sense of the global trade on arms transfers. And it basically has different table types, but you basically have to email them to get that data. So we are going to work with more readily available data sets. There's a SIPRI Arms Industry database. So it contains information on arms producing and military services companies or arms companies. It provides public and private companies, but excludes manufacturing or maintenance units of the armed forces. So I'm looking at this graph. So this is basically a list of defense companies in the world that are by arms revenue the largest companies. They are the major supplier of weapons. They are the major manufacturers, maintainers, some of the largest research and development institutions about any defense program. So at the top, you would have Lockheed Martin, Raytheon, Northrop Grumman, Boeing, General Dynamics, BAE Systems. So the top five are dominated by the United States. And then as we go, for example, further down, let's see what Turkey has. So Turkey has Aselsan as the first in the list as a, what is this? 60th. So it is basically the highest point of entry for Turkey into the list. Then there's Baykar, the Bayraktar and Baykar drone makers, unmanned aerial vehicle. And you're going to notice that there's something called 94% change in arms revenue between 2021 and 2022. And I'm looking at the list. I don't see any other company other than Baykar that increased its arms revenue almost. It doubled its revenue. So it's from sales of drones to Sub-Saharan Africa, Central Asia, North Africa, but also Ukraine, quite a large deal. We also have TAI, Turkish Aerospace Industries, in the list, and Roketsan in the list. This basically is just a very simple visualization on the list. So data for SIPRI top 100 for 2002-2022 exile. So let's start playing with data to see what we are going to do. So these data sets are not as complicated as the ones that we worked with. So instead of CSV, they just work with Excel because the size of data is extremely small. So it's much smaller compared to World Bank data or United Nations data that we work with, very large data sets. So in those, CSV is the most preferred file format, but these data sets are much smaller. So for those, we can work with Excel. So let's click on this and let's download this and see what data it contains. So it's an already formatted database. It practically gives you the rank for 2022, 21, 20, 2019. So it goes all the way back to 2002 when SIPRI started collecting data about this specific data group. And so it goes all the way down to 2022. So in 2022, Lockheed Martin, Raytheon, so we still have the big five from the United States. So the first thing I'm interested in doing is I want to select this graph. And I want to just format this as a table. I have headers, so I converted this into a table, a rankable table. So arms revenue as percentage of total revenue. So companies can actually get revenue from other sources as well, different contracting, contracting jobs. So when I sort this in a descending fashion, it initially gives me some missing data, but then in terms of which companies get the most percentage of their total revenue from arms. So we have India, South Korea, Turkey, France, and so, for example, Turkish companies have a tendency to be, for example, uniquely 100% arms manufacturing and arms sales companies, such as those from India, South Korea, France. Sometimes companies diversify into other services as well, consultancy, services provision, maintenance provision, those kinds of things. So let's close this and let's download the data for total arms sales for SIPRI. And let's see what this data set contains. It is practically just in billion terms. It gives you the increase and decrease in total arms sales. So this doesn't really show me what I'm looking for. So I am going to go back to my top 100 list. And I'm interested in looking a little bit at the general histogram and descriptive statistics of the total revenue of these companies. So I'm interested in looking at all of these companies, and I want to see how clustered and how distributed these companies are when it comes to defense revenue. So there are different ways of visualizing this. So, for example, I'm getting rid of column D, E, F, and G. I'm trying to just bring it into the format of company and total revenue. So I don't also need those. So the first thing I can do in a data set like this, I can, I'm going to rank them based on total revenue, of course. So I need to format as table. My table has headers. Yes. So let's have a look at this in a descending fashion. For example, total revenue for 2022, actually we have different groups in the list. So let's clean this as well. Table rows: Norinco, Avic, General Electric, Raytheon Technologies. So these are essentially richest companies that also do defense manufacturing. So we have Mitsubishi, for example, from Japan, which also produces motorbikes, engines, even air conditioning units, not necessarily military related. So this gives us a total revenue of those companies, including their military applications. So what I'm interested in right now, let's also get rid of column B. So we have just rank and total revenue for 2022. So let's see. So it starts from 5. I'm interested in the distribution of the first 25 companies and look how the visualization goes. So is one company, for example, disproportionately wealthy compared to others? So one way of demonstrating that is a hierarchy graph. And this hierarchy graph, let's convert this into, sorry, it's not that one, it's this one. So let's name this as well. It is the hierarchy graph of top 25 companies that they're not purely defense companies, but indeed that operate in defense sector. Norinco, for example, I have no idea what Norinco is. It would be a good idea to have a look, for example. What is Norinco? Oh, okay. China North Industries Group Corporation Limited. So it is a Chinese state-owned defense corporation that manufactures commercial and military products. So, okay, the largest total revenue company that we have for 2022 is not an American company. It's actually a Chinese company. What is Avic? Is also Chinese, Avic Industry Corporation of China. So Aviation Industry Corporation of China, Chinese state-owned aerospace and defense conglomerate headquartered in Berlin. Okay, so General Electric, that is American, Raytheon, Boeing, Lockheed Martin, fine, but the top 2 is no longer American. The top 2 are actually Chinese. So that is quite an important, for example, revelation to have with regard to 2022 values. Let's play with 2021 values 1 year before, and let's, for example, look at, so what was this, sorry, was this total revenue we looked? Yes. Let's look at arms revenue, because we looked at total revenue, which may include military and non-military applications as well. So I'm interested in looking at arms revenue for last year before this data set for 2021. So I am going to delete column A so that I have only rank, company, country, and arms revenue. I will get rid of these as well. Delete. So first thing I would do is I would look at, should I include the country? Maybe just I should cut the country. Oh, I can't do that on a merge cell. Anyway, so I am interested in just looking at the top, how many countries? So let's look at the top countries and see whether Excel is going to recommend a chart, and no, because we have to format this. So I'm going to just take this, paste it here, take the1, and I'm also going to paste this here so that I have company name and its total arms revenue. So now I am going to select the first, let's say, 25, and then have a look at the recommended charts. And in a simple bar graph, it looks like Lockheed Martin, Raytheon, and Boeing. But Lockheed Martin is really, really, ahead of, quite a lot of those. And Lockheed Martin, in terms of its arms revenue, largest defense companies by arms revenue 2025. Revenue 2025. We see that Lockheed Martin is already quite ahead of it. Now I'm interested in, I mean, we have about 100 biggest defense companies. I'm interested in a histogram. What is the general range of companies when it comes to defense sales? So I will be selecting these both columns and go insert a histogram. Let's carry this up. Let's call this histogram of largest defense companies by, what is this? Arms revenue 2021. So I noticed that most companies are clustered around the area between $850 million and 7 point, I think these are in the billions. So we have only one company, Lockheed Martin, which is too far ahead of other companies here as well. We can increase the number of bins here in order to see whether formatting data series can give me a better idea about defense companies in the lower end. So I already have 9 bins. So let's see if I increase the number of bins, will this, relationship change? No, I mean, we really have a large group of top countries that are in between and in a smaller end of this margin, and then it declines very sharply. So there's no curve here. There's no like curvilinear dynamic happening. It is just like an increasing, logarithmically increasing value. There is some slight increase among those companies here, but Lockheed Martin is disproportionately, high performing in terms of its arms of revenue. So let's see if the summary statistics give us any interesting insight over this. So let's look at descriptive statistics. It asks me to have an input range. So I'm going to the input range. I'm not selecting the header. So beginning with Lockheed Martin, I am going down, 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 all the way to the bottom. Make it. These are grouped by columns. Again, if this was a data series that is horizontally distributed, I would say it's grouped by columns, it's grouped by rows, but this one is flowing vertically, so it's columns. You need to select the summary statistics option, and the output table has to be somewhere underneath here, someplace where I can paste this. Okay, so practically, let's see what the measurement is for those. Total revenue are in millions of US dollars. Is it really? These budgets are incredibly high. Let me have a look. Arms revenue, what does that say for D? Allow constant US dollars. Oh my God, these are like enormous. Arms revenue figures for are rounded to the nearest 10 million. These are crazy budgets, guys, really. So from here on out, it basically allows me to look at the mean of those countries. So the arithmetic, the arithmetic average of the data set is at, so if this is 609, are these billions? I'm still trying to wrap my head around how large. Let's look at the Lockheed Martin arms revenue 2022. 66 billion. Oh my God, these are crazy numbers. Okay, so this is actually like 60 billion. So we have to add, the arithmetic average is so 6049 123 123. So it's about, yeah, it's about 6 billion. This is like around 6 billion US dollars, if I'm not measuring it incorrectly, which means that the average arms revenue of a top 100 defense company is 6 billion US dollars. And then you wonder why we don't have peace in the world. Okay, so the standard error, it gives the accuracy with which a sample represents a population. So this standard error is very large. A standard error of this size gives us a sense that the sample has a very large variance to be able to represent the broader population. Of course it does. So median is the actual middle value. The actual middle value in the data set is 2.5 billion US dollars. And the reason why median is 2.5 billion dollars, but the mean is 6 billion, is Lockheed Martin is just like ridiculously large that it is pulling the mean towards the more extreme end. The mode, which is the most frequently occurring actual number in the data set is 1.4 billion US dollars. See who these are. Yes, it's Fluor, Parsons, PGS. I have no idea what these groups are, but anyway. So standard deviation measures the amount of variation or dispersion in a set of values. This is absurdly large. A very large standard deviation suggests that the values are extremely diverging from the arithmetic mean. We do have an arithmetic mean, but it's basically pulling in both directions so much that is really out of control. The same goes for sample variance. How varied the sample is, meaning that the tendency of the data spread is towards tails, and the same can be seen in terms of kurtosis. A high kurtosis value means that the data is extremely pointy, and then a low value is kind of flatter. But as you can see, the data is absurdly peaked with more weight is among companies that are on the lower ends. So this is an extremely deviant data set with very big, high kurtosis means more of the variance is due to infrequent. So this high kurtosis means that the variance is due to infrequent extreme deviations, which means the curve, it's not even a curve, it's just like a hill, is very pointy, if you will. A lot of the data is clustered in the lower end. And then a positive skewness, an extremely positive skewness means that the tail of the curve is towards the right hand side, meaning towards higher values. And the cluster is among lower values. The distance between Lockheed Martin and Megit, between Lockheed Martin in terms of their revenue. So the minimum is Megit, which has $850 million annual revenue, the maximum being the enormous revenue of Lockheed Martin, some of the total number. So among at least the top 100 defense companies in the world in 2021, the total arms revenue in 2000 was $604 billion US dollar for top 100 countries. Yeah, it's pretty depressing, but yeah, this is basically how we get the data and how at least look at the data, how we're using the data. Good. So let me open up a new Excel sheet, a blank one. Let me copy this entire 2021 figures. Everything I see here. Let's see if I can directly paste it into a new one. So let's close the extra one. Let's copy them all here. Okay. And let's save the new one as IR202-11 SIPRI. Good. So this is the sheet that says top 100 defense companies. Right. We have everything here. So I can just get rid of my work on defense companies because I'm going to do something else now. Multilateral Peace Operations Database, SIPRI Military Expenditure Database. Let's work with this. SIPRI Military Expenditure Database gives the annual military spending of countries since 1949, allowing comparison of countries' military spending in local currency at current prices in US dollars at constant prices and exchange rates, and a share of the GDP. Now, remember, we actually did work with military expenditure data at the World Development Indicators. We will not be doing this, but when we were working with this before the midterm, there is actually a military expenditure data here. Military expenditure, percent of general government expenditure, military expenditure current local currency unit. So if you are going to do military expenditure for Turkey, the local currency unit is Turkish liras, for example, or if you're going to do multi-country comparison, it is US dollar. Now, when you click on this I information, notice that the data comes from Stockholm International Peace Research Institute. So the raw data is supplied to the World Bank from SIPRI. So the original data for these military expenditure statistics are at SIPRI, which is why we are going to be dealing with the original data. So let's click on the SIPRI military expenditure database, this right here. The SIPRI military expenditure database contains consistent time series on the military spending of countries for the period 49 to 2023. It's the largest continuous data set on military expenditures of the world. Based on open sources, meaning every single year, every country's defense ministry publishes the statistics of their defense expenditure, which goes to the statistical offices of those countries, and then they publish it. We assume it is correct. All countries have secret defense programs and whatnot, so this only contains publicly available data. We can't really do anything about secret programs. So access the military expenditure database directly at milexsipri.org. Now it gives you another interface, just like the interface you use with World Development Indicators or the United Nations. It contains a list of countries which you can add all, or remove. So let's try working with all of the countries. So when you click on add all, it takes all of those countries into your selection box. You can remove countries if you're doing like specific country analysis. Regional totals, I don't want. Local currency financial years, no, I don't want local currency. I want just current US dollar. Share of GDP per capita, share of government spending. Let's just work with just current US dollars. Let's start simple. Only current US dollar military expenditure for all those countries, beginning from 49 all the way to 2023. We export this. Wait, for some reason. Oh, wait. So, okay. Here it says export options. You can do screen preview. So it basically posts the data here. Again, compared to the kind of data set sizes we worked with World Bank or UN, these are very small data sets. So there's really not a big problem if you download the Excel version. We tend to want CSV files as the data starts to get larger and larger and larger. But for smaller data sets, Excel version is not a big problem. So let's select Excel and export. Okay. So the first page is the front page. It explains to you how the data was collected, the notes you need to read before dealing with this data. And this is the actual data set that we will be working with. Military expenditure by country in millions of US dollar at current prices and exchange rates. It has a country tab, and then years are grouped in rows. These are all US dollar current value equivalents of countries in the list. So from here, let's do a correlation analysis. Let's correlate what? Usually in international relations theory, it is suggested that security concerns flow directly across borders. This is called the regional security complex theory. Basically, a group of countries that are neighbors to each other share similar threats, or if they are enemies, their relationships of animosity and or friendship, for example, cause countries to act in very similar fashion. So I would expect in a security complex, countries would have similar increases or decreases in defense spending. So for this exercise, let's look at, again, Turkey and its neighbors. What was the defense spending patterns for Turkey and its neighbors? So I am going to open up a new sheet. I'm going to open up a new sheet. And what I'm going to do is that I am going to copy this, or maybe not, let's not do it one by one. Let's do it all together. So right now I'm keeping pressing the command button on my Mac. On PCs, you should be holding the control button. We will be selecting multiple rows together. So I selected row 6 and I'm keeping holding, because I'm on a Mac, I'm holding the command button. Let's pick Turkey and its neighbors. So Africa, I don't really need. Central America, no, Turkey is not there. Asia and Ocean, Europe. Turkmenistan, Uzbekistan, no, nothing here. So, okay, Central Europe. Let's start with Bulgaria. Then let's go. Let's take Romania. Why not? Slovenia. There are also, because the data set starts from 1949, you have USSR and Yugoslavia in the list as well. Some of those countries are no longer with us, but if you're doing historical analysis, for example, you take their figures. Armenia, Azerbaijan, Georgia. Let's take Russia and Ukraine as well. We have USSR, but after 1991, we don't have it. Let's take Cyprus, Portugal, Sweden, Switzerland, okay. Let's take Iran, Iraq, Syria, Turkey. Okay, we have sample lists of Turkey and its neighbors. And let's copy those and paste it here in the new sheet. Let's see if... So remember, to be able to do a correlation analysis, I need as many years as possible because I need to follow a long-term trend in order to be able to assess whether something increasing also correlates with other things increasing and decreasing. So I have pasted this here. Since it's already selected, I am going to go to my other worksheet on IR202 week 11 SIPRI. And I will continue working on this in a new sheet here. I'm not going to paste special, I'm just going to paste. It's not. Let's copy this again. Let's paste this here. Am I done with military spending data? Or let me have a look. Maybe I'm not. So let's also take let's take column A in its entirety, and then let's have a look at the entire 2023 figures. Let's copy countries and 2023 figures. And then let's create a new sheet in our actual worksheet and paste them here. Let's call this Turkey neighbors correlation. And let's rename sheet 3 as 2023 defense spending, because we'll be doing different things with different ones. Okay, so here we have Turkey and its rough neighbors. And what I'm trying to do here is that I am looking for as complete as possible data. So because Syria is under war, its data is not very good for beginning with the beginning of the war, 2011. After that, we can't really get data from it. And for Iraq, so we will be able to only do correlation. I don't want to take out Iraq, but yeah, because we do not have data after 2012 for Syria, and for Iraq up until 1990, after 2003, beginning of the war there. Unfortunately, I'm going to just delete those two from the data sets because it is incomplete data. I can't really work with incomplete data. So we are shifting cells up. So the complete data that we have, as much as possible, is up until 1995. So beginning with 1995, I'm just deleting everything before so that I have a correlationable. I don't know if that's a word. So we are now shifting cells to the left, taking 1996, putting this at the end of the data set. Now we do have, and I'm assuming this is the Soviet Union, but what the hell? So 1996 to 2023 is the only reasonable, logical, complete kind of data source that we have. So I'm interested right now is which of Turkey's neighbors have their military spending correlated, meaning whether they have a similar threat perception, whether they have similar patterns of animosity or friendship. To be able to do that, we explore how all of these countries' military spending have changed. So first thing, to look at the general trends, just by visually, I'm selecting this all. And let's go to insert. Let's search just a basic chart, just a line graph to see what's happening. So line graph of military spending of Turkey and its neighbors, annual change. So Russia has quite a high military expenditure in US dollar terms, but keep in mind that Russia also has a nuclear arsenal, so it's a very expensive thing to maintain. Turkey is somewhat the second highest up until this Ukraine, yeah, of course. So beginning with the second war in Ukraine, Ukrainian military spending increases quite significantly as well. So because these two countries are fighting, Russian and Ukrainian military spending increases all together. So just by looking at a trend on a graph, I can actually see some trends, but does it hold statistically as well? That's very interesting. So let's look at the data. Let's look at data analysis. Let's look at correlation. And let's pick our input range. So my input range starts from 1996. I will try selecting country names as well, see what happens. Maybe it gives me an error, who knows. I am selecting countries. These are grouped by rows. I have labels in the first column. Let's see if it gives an error if I do that way. Because the labels are country names. The output range has to be somewhere right below a comfortable empty window. Let's see what happens. Okay. I have a correlation matrix for countries to see whether the defense spending changes across the years. So just by looking at 0.86 is quite high. Armenia, Romania, these are very, very high correlations. This is high. These are high. Yeah, kind of high-ish. 0.0, sorry. That's very weak. 0.5. So these are all, let's say, moderate correlations. These are very weak. This is, again, moderate. Weak. These are weak. These are moderate, 0.5. These are very weak. They're moderate as well. Ukraine somewhat, strong. It's not nothing. So I'm just, selecting key trends one by one from the list to see. This is strongish as well. This is strong as well. These are all moderate correlations. Okay, so here the highest defense spending correlations I have is between Bulgaria and Romania, Armenian Bulgaria and Armenian Romania, which is interesting. Armenia and Azerbaijan, yes. Russia and Armenia, and Russia and Azerbaijan, and Ukraine and Armenia. So the military spending of these countries change quite significantly together. These are extremely correlated. So the highest defense spending correlations are between Romania, Bulgaria, Armenia, Bulgaria, Romania, Russia, Armenia, Azerbaijan, and Ukraine, Armenia. Does it make sense? I mean, some of these countries are, yes, neighbors. Russia, Armenia, and Azerbaijan, yes, they have fought wars, but it's very, very interesting that um, um, these would be correlated. So now that I have a strong correlation, the next step, of course, something you will learn in your later courses, is that looking for the causes of these. Why are these countries' defense spendings are increasing and decreasing? Now that I observe that they do by finding correlations, why these change and what causes them to change is one level up after this. So you are going to be doing causal analysis. What causes these variations? You would be doing survival analysis, Weibull distributions, so on and so forth. Now, here I notice that Turkey's defense spending is moderately correlated with most of its neighbors. So there's no specific case in which Turkey specifically views a country as a threat or an ally, for example. So the highest are between Azerbaijan and Russia, in which sense Russia is a strategic rival, but also a very close trading partner. Azerbaijan is an ally directly. So higher correlations don't really mean that these countries are fighting or enemies. It means that there's a strategic rationale that causes these countries' military spendings to increase and decrease altogether. Cyprus seems to be completely unrelated to the rest. Cyprus defense spending has the lowest correlation with most other countries in the sample. Other than that, yes. I mean, if we were in a classroom situation, we would be discussing in terms of, I would ask you, why do you think these are happening? Actually, Iran as well. Iran's defense spending has the lowest correlation with most other countries in the sample. And Cyprus spending has the second lowest in that case, because Iran is really unrelated. It's related to moderately Russia, Georgia, and Azerbaijan, because this is a strategic partner. These two are neighbors, so it makes sense. But the relationship of military spending is not as high as these are. So all of these red relationships caused me to do a second range analysis on why these correlations are happening in the way that we see. So for example, let's look at the highest correlation. What is it? Azerbaijan and Russia. Let's select Russia, Azerbaijan. Let's also select the years. Let's go insert. And let's see if it's going to give me a plot graph. No, it's not giving me a plot graph in the way I want. Maybe I will deselect. Let's do plot graph again. Yeah. So this basically shows, no, it does not. Let me try once again. Let's select this specifically towards the end. this specifically. And then let's try again. Yeah, so this, I will show you how to modify axes and X and Y values, but this basically gives you the trend line of the spending correlation between Azerbaijan and Russia. And the R square here, basically how well increases in Russian military spending alters Azerbaijan's military spending. The R square is 0.89, almost 0.9, which really suggests that Russian and Azerbaijan's military spending are correlated. And then, of course, we would do something like correlation between Russian and Azerbaijan spending. What's the date? 1996 to 2023. Quite a large correlation. And then, of course, in a classroom setting, I would basically initiate a discussion asking, why do you think this is happening? What are the possible reasons? But since the point of these recorded lectures is to prepare you for the exam, I wanted to give you something you can just rewatch, stop and rewind as much as possible. Now, let's look at the final part of this military expenditure by country only for 2023 values. So here I only need the country names, and I have to get rid of the missing values. So normally in a World Bank or UN database, but when selecting these countries and country groupings, it asks you, but now we have to clean it manually. It's okay, not the end of the day. So I'm basically deleting rows that contain country, continent or subcontinent grouping. So I'm deleting Africa, North Africa. Oh, sorry, delete them. Sub-Saharan Africa. I only want country names to stay. And while I'm at it, it is best to also delete the empty pages, empty cells. So Libya 2022, missing value. Let's get rid of this because if we don't know the actual data, there's no point in doing any analysis. Djibouti, Eritrea, let's delete them. Missing values, not available values. Sudan, because there's war, there's insufficient information, we don't know. Americas, Central America and the Caribbean, delete those. Cuba, we don't know. North America. So I'm just selecting everything that is a continent and subcontinent, and also contains missing values. South Asia, Afghanistan, East Asia, North Korea, military spending data is usually not available. Indonesia, Indonesia, Laos, Vietnam, Central Asia, Turkmenistan, Uzbekistan, Europe, Central Europe, Czechoslovakia. It says XXX because Czechoslovakia no longer exists. It's Czechia, so it changed name. Also, German Democratic Republic. It was the name during the Cold War, but Cold War ended, so German Democratic Republic became Germany. So we no longer have those countries. Yugoslavia no longer is around, so it's XXX. But since the data set contains values from 1949 all the way through 50s, 60s, and 70s, these older names are here. So we are selecting USSR, no longer with us. Iceland, 0. Yes, there are some countries who really do not spend any money on their military. Iceland has no military spending. There was another one. Costa Rica also, but they don't have a military, so they don't have military spending. Qatar, Syria, North Yemen became Yemen. So I'm basically selecting these missing values. I say delete. Yemen also doesn't have recent values. So I have a clean data set, hopefully, that now I can convert into a table. Go to here, format as table, pick any one that has sortable first rows. Make sure your data is selected in the proper row. Make sure that if you selected the headers, my table has headers option is selected. Let's look at it in a descending fashion. Of course, United States of America has the largest defense spending in the world, followed by China, Russia, India, Saudi Arabia, United Kingdom, Germany, Ukraine, France, Japan, South Korea, Italy, Australia. So this is basically the list of countries who spend the most in US dollar equivalent around the world. So we can do things like pick top, I don't know, 25, insert a tree map to see the general distribution of those. No, get this one. If you want, you can change the colors in any way you want. It gives you basically by how much United States defense spending is enormous. So it's like China, Russia, France, Ukraine, Germany, India combined almost, even a little bit Saudi Arabia, Japan. It's enormously large. So top 25 countries by defense spending 2023. Also by current US dollars. Interesting. So let's have a look at descriptive statistics of this. I'm going fast because you can stop and replay at any time you want. So yeah, so Iceland, Panama, Costa Rica, these countries have no military spending. They don't have any military. They have police, but they don't have military. These are grouped by columns, no labels and rows. The output range is, let's put it here. Okay. So these are US $1 million in current prices. So it is, I always have trouble. Let's see, US military spending. $916 billion. Oh my God. So this is okay, billion, which means that the arithmetic average of defense spending for 2023 was around 15.5 billion US dollars in the entirety of the data set. The standard error, it basically gives me how likely it is that the sample mean varies from the true population mean. So it varies by around 6.3 billion US dollars. So the majority of the sample is from the arithmetic mean 15.5 billion US dollars plus 6.3 billion minus 6.3 billion essentially. The median is the actual middle value of the data, but it is much lower than the mean because the US is pulling the mean to higher numbers, because we have an extreme country together with China and Russia pushing this all the way up. Modes are the most frequently occurring number, which is at the end. And the standard deviation in that sense is the dispersion of values. So a high standard deviation. In this context, the standard deviation is nearly 78.6 billion US dollars, which is very high. The values are widely and wildly distributed. Sampler and sampler, it basically gives you, sorry, sample variance renders the standard deviation results robust. Now, kurtosis, it's an extremely high kurtosis. The peak of the cluster is extremely high. And usually when we look at money value, so for example, income groups in a country, the poor is usually very poor. So the number of poor people or the number of poor countries are extremely high. You usually have a very small number of extremely rich people or extremely rich countries, which is why kurtosis of anything related to money and world has extremely high kurtosis. So it's basically very, very, peaked. Peak of the cluster is extremely high. The data is the data is super clustered. And the skewness means that it is skewed. The data cluster is skewed very much towards lower values. There is an extremely high number of low military spending countries, which basically clusters everything there. The range is between 0 and the top United States of America, maximum, minimum values, remember what we discussed before. So we were saying the world spent 2.4 trillion US dollars, right? So it basically shows it here. The sum of all countries' military spending was 2.38 trillion US dollars. Let's do a histogram to visualize these things. Let's go to insert. Let's do a histogram. Yeah, this is absurd. Histogram of countries by military spending 2023 current US dollar values. Oh my God. So you are going to see that there is only one point that only like extreme end the right, that is United States. China doesn't appear in any of the bins of this histogram until here. This is China and this is Russia. So as with top defense companies, we basically have lower values clustered in the lower ends, with one extremely wealthy military spender right there, format data series. Let's increase the number of bins. I don't know if it's going to be any helpful in terms of making this have more sense. But yeah, I mean, it is just crazy. Can I add a trend line to this? So it doesn't even allow me to do that. Yeah, so it gives you how wildly unequal the world of defense spending is. So on the one end, you have this change. On the one hand, you have the majority, extreme majority of countries are kind of low spenders in between 0 to around is it 3 billion? Is it 30 billion? I think it's around 30 billion. And then you have countries that are the upper end. And then here we have Russia, the third spender, then China, then the United States. So it also gives you a sense of how unequal the world is, but then the world is, yes, unequal, of course. But it shows you how wildly powerful United States is from a defense spending point of view. Even though China is extremely powerful, look at the gap between United States and China and Russia and the rest of the world. So yeah, I mean, in this lecture, you learned how to pull data from SIPRI and then do some basic visualizations out of top defense contractors. Then do a descriptive statistics table, interpret the results, pull the data for Turkey's neighbors, do a correlation analysis, one very simple graph. Make this pretty, why not? What would you like to have? Okay, like this. Shiny. No, we need to. These color codes are so bad. It's like so unhelpful. Anyway, oh, this is even worse. Anyway, next time I'll just like create some random color code, and then you learned how to do just a very basic line graph, and then I think the most important part of this was doing a correlation table and a plot graph out of this, interpret the results, and then for 2023, look at defense spending figures, do a hierarchy graph, do a summary statistics table, and then produce a histogram out of this. And so save your work so that it stays with you forever, right? Okay, so thanks so much for joining me this evening. Again, let us know if you have any questions. I'm happy to answer any questions you have. We have 2 course assistants that are very good at these things. They will help you with anything, whether I do this on a Mac. If you have an older Excel or a PC, you can't find certain things. You can either go here and help, use the help function, or you can email any one of us. But that's pretty much it for today. Thank you so much for joining me. Take care, and I'll see you on Thursday. Bye-bye.